Today we will see the Kirchhoff's current law or a KCL in the network analysis. So this Kirchhoff's current law, commonly also known as Kirchhoff's first law or Kirchhoff's junction law. So let's see this Kirchhoff's current law. So according to the Kirchhoff's current law, the algebraic sum of all the branch currents at given node is zero at all instant of time. Or in simple way, we can say that at any node or a junction in the network, the sum of the currents flowing into the node is equal to the sum of the currents flowing out of that node. So let's understand it by taking a simple example. So let us say we have a node in the network which contains a 5 branches. The current in these 5 branches are from I1 to I5 respectively. So here as you can see, this current I1, I2 and I3 are entering into the node while current I4 and I5 are leaving the node. So here we use the following sign convention that whenever the current is entering into the node, we will consider it as a positive current. While if current is leaving the node, then we will consider it as a negative current. So here as you can see, current I1, I2 and I3 are entering into the node, so we can consider them as a positive current, while current I4 and I5 are leaving the node, so we can consider it as a negative current. And according to the Kirchhoff's law, the algebraic sum of all these currents is 0. So we can write I1 plus I2 plus I3 minus I4 minus I5 is equal to 0. Or we can write it as a I1 plus I2 plus I3 is equal to I4 plus I5. That is, the currents which are entering into the node is equal to the currents which are leaving the node. Now earlier we had seen that current I can also be defined as Q divided by T, that is the rate at which the charge is flowing. So we can write this equation as Q1 by T plus Q2 by T plus Q3 by T is equal to Q4 by T plus Q5 by T. So here we had written these currents in the form of charge, and we can simplify it as Q1 plus Q2 plus Q3 is equal to Q4 plus Q5. So we can see that the charge which is entering into the node is equal to the charge that is coming out of the node. So we can say that this Kirchhoff's current law is nothing but law of conservation of electrical charge. That means the sum of the charge that is entering into the node is equal to the sum of the charge that is leaving the node. Now let's take one numerical and see the application of this Kirchhoff's current law. So here we had given one circuit which contains a three nodes A, B and C, and the current I1 to I6 are the currents which are flowing through this circuit. We had given some of the currents and we need to find the current I6 that is entering into this node B. So to find this current I6, we need to apply a KCL at node B. So let's apply KCL at node B. So after applying KCL at node B, we will get a I3 plus I6 is equal to I1, as current I3 and I6 are the currents which are entering into the node B while current I1 is leaving the node B. Now here we had given I1 is equal to 2 ampere, so we can substitute this current I1 as a 2 ampere in this equation. So we can get I6 plus I3 is equal to 2, or I6 is equal to 2 minus I3. So let's say this is the equation 1. Now here still current I3 is not known. So to find this current I3, we need to apply a KCL at this node C. So by applying KCL at node C, we will get a I2 plus I5 is equal to I3. Now here we had given I5 as a minus 4 ampere. So we can substitute this I5 as a minus 4 ampere in this equation. So we will get a I3 is equal to I2 minus 4. And let's say this is the equation number 2. Now here also this still we don't know this current I2. So to find this current I2, we need to apply a KCL at this node A. So let's apply a KCL at node A. So applying KCL at node A, we will have a I1 plus I4 is equal to I2. Now here current I1 and I4 are the known currents, that is 2 ampere and minus 1 ampere. So we can write as 2 minus 1 ampere is equal to I2, or we can write I2 is equal to 1 ampere. So now as we know this current I2, we can substitute the value of this current I2 in this equation number 2. So as we know the current I2, so we can put this value into this equation number 2. So we will get I3 as I3 is equal to I2 minus 4, and I2 is 1 ampere. So I3 is equal to minus 3 ampere. So now we also got this current I3. So now we can easily find this current I6. So we had seen that equation 1 that I6 can be given as 2 minus I3. So let's write it, I6 is equal to 2 minus I3, and substituting this value of I3, we will get I6 as 5 ampere. So in this way, using the Kirchhoff's current law, we can find the currents in any circuit. So I hope you understood what is Kirchhoff's current law, and using this Kirchhoff's current law, how we can find the different currents in the electrical circuit.